So if you recall from the math lab that we did at the start of this lesson, when we wanted to find the inverse of f of x equals 3x plus 2, all divided by 2, we listed this operations that were occurring on the x in order of operations. So first the x got multiplied by 3, then we added 2, then we took that result and divided it by 2. To find the inverse equation, we do those same operations, but in reverse and with their inverse. So the inverse of dividing by 2 is multiplying by 2. So we start by multiplying the x by 2. Then the inverse of adding 2 is subtracting 2. So now we have 2x minus 2. Of multiplying by 3 is dividing by 3. And don't forget, you have to first do the 2x minus 2 before you divide the entire result by 3. Then you use your inverse notation to denote the inverse, and that -1 superscript is the notation for inverse. So this reads f inverse of x is equal to the quantity 2x minus 2, all divided by 3. The equation for the inverse, rather than having to graph it and switch the x and y, is to replace the f of x with a y and then switch your x and y algebraically in the equation. So x is equal to the quantity 3y plus 2, all divided by 2. Next, we're going to solve this equation for y. To get the y by itself, we first have to multiply both sides by 2. So now we have 2x is equal to 3y plus 2. Then we'll do the minus 2 from both sides to get the constant away from the y. And now we have the quantity 2x minus 2 is equal to 3y. And finally, to get the y by itself, we're going to undo the multiplication with division. And we're dividing the whole side by 3. So that leaves us with f inverse of x equal to the quantity 2x minus 2, all divided by 3. So in example 2, we're going to find the equation of the inverse by following these 4 steps. Step number 1 is to replace f of x notation with y equals notation. Then step number 2, we switch the x and the y's position. So now we have x is equal to 3y plus 9. Next, we're going to solve this to get y by itself. So we'll subtract 9 from both sides, and we have x minus 9 is equal to 3y. Then we're going to divide both sides by 3, and the inverse, f with a little -1 superscript of x, is equal to the quantity x minus 9, all divided by 3. So pause the video and try B and C on your own. Remember that division is the same as multiplying by the reciprocal. Then you can resume the video once you've given those a try. Okay, so in example B, we're first in step 1 going to replace the function notation with y equals. Then step 2, we switch the x and the y. Now we're going to undo this division by multiplying. So we multiply both sides by 2, and we have 2x equals -5y plus 3. Now to move the constant to the other side, we'll subtract 3 from both sides, and we have the quantity 2x minus 3 equal to -5y. To undo the multiplication of -5, we multiply both sides by the reciprocal of -5, which is -1/5. Then we've got to distribute over the parentheses to each term in the binomial, and we'll have -2/5 x plus 3/5 is equal to y. So f inverse of x is -2x over 5 plus 3/5. In example C, first step was to change that function notation to y equals, and then step 2, we switch the x and the y. Now we want to get the y by itself, so we're going to subtract that constant of 3/4 to the other side, and we have the quantity x minus 3/4 equal to 1/2 y. To get y by itself, we're going to multiply by the reciprocal, which is 2, and then distribute that 2 over the parentheses to each term in the binomial. So we have 2x minus 3/4 times 2 over 1, and that is going to be 6 over 4, which reduces to 3 over 2. So f inverse of x is 2x minus 3 over 2.